Bismillahirrahmanirrahim. In the name of Allah Almighty, the most merciful and the most kind. I, Engineer Bilal Ahmed, presenting on the topic of design and analysis of protection scheme for 500 kV Rawat station. I have done this project under the supervision of Sir Qazir Slan Hamid, and I am presenting to the platform of Agile Technical and Consultancy. Our objective included design and simulate Rawat station in ETAP and then design an accurate economic protection scheme for our Wadri station, which has the main character of surgical accuracy so that only faulty portion is excluded and our power supply to healthy section could be made sure. Our Wadri station has about 5 incoming 500 kV connections, which always act as supplying grids. And then we have 220 kV connections, which sometimes act as a feeder connection and sometimes act as a supplying grid. And then we have 132 kV feeder connections, which are our main responsibility to supply load. This is the certified single line diagram of our Wadri station. Only a few changes have been made recently, which are incorporated in our project. This is our 500 kV portion of Wadri station. Here, 1.5 horsepower protection scheme is implemented, and the bus bars are protected by using current balance scheme or differential protection scheme, and the nodal bus connections have been protected by differential protection scheme. Also, we have here implemented voltage and frequency protection. This is our 220 kV portion, which is also 1.5 horsepower scheme, and it is preceded by 3 winding transformer of 500 kV to 231 and 23 kV rating. And this is our 132 kV portion, which is double bus bar scheme, and it is followed by our feeder connections, which have different length of transmission lines. Here is the normal load flow analysis of our Wadri station, and as could be seen here that on normal condition our grid station is supplying power to its load normally. Starting from our feeder connections section scheme, we have implemented distance protection and directional OC protection, ground scheme sequence protection for our transmission lines whose length is greater than 7.5 km, and for the transmission lines whose length is less than 7.5 km, only directional OC ground and active sequence protection is implemented. For distance protection, we have used 80%, 100 and 150% zones. Then we have our transformers. We have protected our transformers with our differential protection and our front ground and active sequence protection. We have used reverse directional protection here also in order to make sure the selectivity of operation, so that only in case of fault at our specified transformer, the respective circuit breaker would be tripping, and in case of fault at any other transformer line, as there are parallel transformers here, and so in order to make sure selectivity, we have used reverse directional OC protection. For 220 kV and 500 kV bus bars, as discussed earlier, we have used current balance scheme and also overground OC ground and active sequence protection scheme as a backup. We have also incorporated frequency and voltage protection scheme. The frequency relay would allow only plus minus 2.5% frequency fluctuation, and both the frequency and voltage relay are implemented in steps scheme, so that at a first step of about 1.2% plus minus for frequency relay and plus minus 5% for voltage relay, and then here is a step of 2.5 and plus minus 10%. Now we are going toward our live demonstration on Meet app. This is our 500 kV Rawat station. It consists of three portions: our 500 kV portion, 220 kV portion, and 132 kV portion. Starting with 500 kV portion, there are five incoming grid connections at 500 kV portion. The busbar scheme at our 500 kV portion is 1.5 busbar scheme, which is protected by differential or current balance protection scheme. And here we also have voltage and frequency relays installed. Then we have our 220 kV portion, which is also a 1.5 busbar scheme, and it is preceded by three winding transformers with 500 kV to 220 and 23 kV ratings. And then we have two winding step down transformers of various rating to 132 kV, and then we have a 132 kV bus bars which have double bus bar scheme, and then we have our different feeder connections with various transmission line lengths. Starting with our distance protection scheme, we are introducing three-phase part, and as visible here, for the transmission line whose length is greater than 7.5 km, we have used distance relay backed up by our OC relay, and for the transmission lines which have only the length less than 7.5 km, only the directional OC relay is used. And here on introducing fault, this relay is tripping and is being made assured by the backed up relay so that our fault don't travel and the power supply to our feeders will be made assured. Now moving toward here we have also introduced three-phase fault. This is the primary protection, and then we have here our backed up protection. If this protection and circuit breaker fail to operate, then this would be operating. Now let's introduce fault on our 132 kV bus bar. Here we have one main bus bar and one transport bus bar. We are introducing fault on our main bus bar. As could be seen here, on introducing fault on our main bus bar, the respective circuit breaker would be tripped, and then we would shift our load on our transfer bus bar, and then our operation could be started normally. Here it is visible the purpose of reverse directional overcurrent relay, as only in the case when the fault occur here on the respective transformer circuit or transformer line, then the respective circuit breaker are tripping. As there is no tripping on other transformer circuit, and the a continuous supply to overload is make the shock. This is going to isolate all our outgoing connections. Now introducing fault on our 220 kV bus bar. This is our main bus bar, and here we have used ground balance scheme. As it is visible that on all occurrence, the respective circuit breaker would isolate our main bus bar, and then we will shift our load to our transfer bus bar. This is our sequence view. Now we are introducing fault at our nodal connection bus bar. Introducing fault on our tertiary three winding transformer. Here also there is differential protection scheme backed up by OC negative sequence and ground protection. Now the final part is a 500 kV portion. And here I'm introducing part. This is our main bus bar. The respective circuit breaker will isolate our main bus bar and so that the load could be transferred to our transfer as well. Thank you. That's all. We have analyzed our load flow studies, short circuit studies, and designed a protection scheme which was accurate, economic, and of surgical accuracy for our different kind of portions of our organization. The mode of protection design was implemented was overlapping zone protection scheme so that no portion of our grid was left unattended, and also it was observed during our checking that no maloperation was occurred, and we inserted fault on each and every component of our grid station and our protection scheme protected it accurately. That's all from my side. For further queries and information, kindly contact me at my email or my contact number. Thank you.